This video is going to cover the two-sample z-test for a difference of proportions. And here's a little recap of some of the important formulas we're going to look at while we're using this. One, p hat c, the combined proportion, where we pool them together and to make one sample. So we add the x's together and add the n's together, and we get one proportion for both of them because we're treating them like they are the same. Then our z-score formula is the difference in the proportions minus our hypothesis, which is usually 0, divided by the standard deviation, which is going to be the p hat combined we're going to use in this formula. Now, on the formula sheet, sometimes it writes it like p hat c times 1 minus p hat c, and then it does 1 over n1 plus 1 over n2. You can use either type of formula you'd like. We have to make sure we're checking that it's an independent random samples. We need to check that both samples separately are less than 10% of the population. And then we're going to check both NP combined and N1 minus P combined, and then N2 times P combined, and N1 minus P combined, or N2. So we're going to use P combined for our large sample condition and for our standard deviation. Okay. In a recent experiment, 180 volunteer children were randomly assigned to receive either a stuffed animal or a blanket to help them sleep better. Of the 100 children who received the stuffed animal, 34% reported better sleep. For the 80 children who received the blanket, 75 reported better sleep. Is there convincing statistical evidence that the proportion of children with improved sleep with a stuffed animal is less than the proportion with a blanket for all children, like the ones in the study? Use an alpha, this time, of 0.01. So this one's going to change our alpha a little bit, which will be a good example. So we start with choose. This is a two-sample z-test for p hat 1 minus p hat 2, a difference in proportions. Our alpha is 0.01. Our p hat for the, I'm going to put S for stuffed animal, is 34%. Our N for the stuffed animal is 100. Our p hat for the blanket was 0.75. And the N for the blanket is 80. Okay. And our parameter is the true difference in the proportion of children with improved sleep with a stuffed animal versus a blanket. Okay, so we want to know the true difference in the proportion of kids that feel like they sleep better. So our evidence for PRHA, so let's write our hypotheses. Our null hypothesis is that PS hat minus PB hat is equal to 0, that they are the same. And our alternative is P hat S minus P hat B is less than 0, because our question says less than is stuffed animal less than the blanket. So I could write it the other way around. I could do P hat B minus P hat S equals 0. And then my alternative would be P hat B minus P hat S is greater than 0. Either one are acceptable, even though the question says less than, but you just have to make sure it's the right direction. The B should be the one that's bigger. And then our evidence for HA is that P hat S minus P hat B is 0.34 minus 0.75, which is negative 0.41. The next is check. So the groups were randomly assigned to treatments. We aren't looking at a random sample. And we didn't sample without replacement. We got volunteers to do this study who were randomly assigned. So the 10% condition does not really apply here. I'm doing an experiment. I didn't do sampling, so I don't need to sample without replacement. But we'll check, let's calculate p hat combined. That's going to be, well, it doesn't tell me how many exactly in each group. So I have to do 100 times 0.34 plus 80 times 0.75. That'll tell me how many in each group, and that'll be over 180. So that's 34, and 80 times 0.75 is 60. So 34 plus 60 over 180 is 94 out of 180. So we do this because our assumption is that they are equal groups. The groups aren't different, so we can treat them as one larger sample. So we're going to check our N1, 100, times our P 0.522, which is 52.2, greater than or equal to 10, and 100 times 1 minus 0.522. I'd like to actually do the math. 0.478 equals 47.8, greater than or equal to 10. And then we'll do it with 80. 0.522, 41.76. That's greater than or equal to 10. Let's see if I can move this over a little bit. Nope. Let me just make myself some room here. Okay, and greater than or equal to 10, 478 is 38.24, greater than or equal to 10. Okay, so we can generalize. Okay, and so we can use a normal model. That's why we do those conditions. Okay, so our conditions are met. Now we're going to calculate. Now in general, our general formula for a z-score, our test statistic is the z-score, is the statistic minus the parameter, which in this case is our null hypothesis, divided by the standard deviation for p hat combined, basically. And so that is the negative 0.41 minus 0. The hypothesis was that there was no difference, so it's minus 0. And the square root of 0.522 times 0.478 over 100 plus 0.522 times 0.478 over 80. And we're going to do this in the calculator, making sure you either don't subtract the 0 because we don't really need to do 0.41 minus 0, or you put it in parentheses for the numerator before you plug in the denominator, or you hit enter, but make sure it's doing the calculations correctly. And I get a z-score of negative 5.472. And then to get, this is my test. This is my test statistic. So when it's asking about a test statistic, that's a z-score. And then to get my p-value, my hypothesis was just less than. So that means I'm going to do negative 99. That's normal CDF. Negative 99, negative 5.47201. And I only multiply by 2 when it's not equal to, and that's not what I have. So we're going to just keep what I get. And it's going to be pretty small. 2.23 times 10 to the negative 8. Don't ignore the calculator when it says e negative 8. That means times 10 to the negative 8 power. Okay, and then the last part is to conclude. We're going to interpret our p-value first, assuming HO is true. P hat S minus P hat B is equal to 0. There is no difference. So we could also say, assuming there is no difference, the proportion of children who sleep better with a stuffed animal than or sleep better with the blanket than the stuffed animal. So there is a p-value chance, that's 2.23 times 10 to the negative 8, chance or probability of getting our sample difference of negative 0.41 or more extreme purely by chance. And then our alpha level was 0.01, but 0.01 is still larger, so our p-value is still less than our alpha. So because our p-value of 2.23 times 10 to the negative 8 is less than our alpha of 0.01, we reject HO. And there is convincing evidence and this is where we want to repeat what it says up here. The proportion of children with improved sleep with a stuffed animal is less than the proportion of children with a blanket. With improved sleep with a blanket, nope, with a stuffed animal, is less than the proportion with a blanket. Okay, so one of the things I'm noticing is we're getting the fact that when we're rejecting, there is convincing evidence. Okay, I'm seeing people reject and say there's no convincing evidence. So if it's less than alpha, we are going to reject. And we have convincing evidence. If it's greater than alpha, we fail to reject, and we do not have convincing evidence. Okay, you've got to get this part right. Okay, the elements. Reject, and we have when it's less. When it's greater than, we fail to reject, and we do not have the convincing evidence.